everyone. Welcome to another Australian Water Association webinar. My name's Rebecca and I obviously work at the Australian Water Association, and I will be your host for this session. Thank you so much for joining us today. The webinar follows the one we did on the Bureau of Meteorology last year about El Nino. We've now teamed up with the Bureau to provide a two-part series for you on water specifically. As many of you are aware, the Bureau's Water Information Program is built on a comprehensive and reliable picture of Australia's water resources to support policy and planning. It provides nationally consistent water information as part of its role and responsibilities under the Water Act of 2007. Today, we'll help you understand how to track and forecast water flows. We hope very much so that you find this worthwhile, as interesting as we find it here at AWA and the Bureau. Soon I'll introduce Dr. Paul, who will be your presenter for the session, as you can see up here on the screen. We'll be recording the session and we'll provide you with a link to the recording afterwards, so you don't need to try and scribble everything down. We'll also be providing links to other resources on the Bureau's website, such as the products and services that Paul will be mentioning. And just before we go any further, I'm going to outline a few of the technical pieces of information just so that you're aware throughout the webinar. So as you can see, and everyone should be able to see, in that little chat box at the bottom left-hand corner of the screen, there is a contact number if you can't hear me or you can't see Paul, or if there's any audio or visual problems, just call that number. That'll go straight through to our Redback conferencing platform, and they'll be able to support you if you have any issues there. This is dial-in as well, so if you call that number, that emergency number, they'll be able to provide you with a dial-in number, of which you can always dial in if you can't hear this properly. If you can't hear, just type in that little chat box and I can make sure that we get it all sorted. So that's easily looked after. You can, at the bottom as well, you'll be able to submit some questions. Now, I just want to stress that any questions, can we please wait until the end, till Paul gets through the rest of his webinar, and he will be able to answer the questions nice and succinctly for you. Just so you know, the webinar itself, Paul is joining us from the Bureau's Melbourne office. Dr. Paul manages the seasonal Streamflow forecasting service for the Bureau of Meteorology. He and his team are responsible for the delivery and communication of the forecast each month and also work to further develop the service. Prior to joining the Bureau in 2013, Paul was a Senior Research Fellow at the University of Melbourne. There he undertook research and lectured on topics of catchment and forest hydrology, including the effects of climate change and wildfire on the hydrology of forested catchments. Paul, over to you. Welcome and thank you for doing this webinar for us.
Wonderful. Thanks very much, Rebecca. So I'm assuming everyone can hear me quite well. I thought, look, today we're going to look at where the water is, and as Rebecca mentioned, my area is seasonal streamflow forecasting, but we'll look at that and a lot of other supporting information from climate, and also look at and what the climate drivers are, and look at the outlooks, and look at where water is throughout the landscape. So I'm just going to turn myself off now, and we'll get started with the webinar. So moving on to the first slide, just to provide you with an outline of what we'll be talking about today. We'll start with recent conditions, look at rainfall and evaporation, where that water is in the landscape in terms of in the soil, in streamflow. Also look at water storages, and we'll also touch on some water sources and trends in our major cities. And we'll finish off by looking at the outlook, including what's going to be driving our climate in the following few months, and what that means for rainfall and temperature and for streamflow as well. So starting by looking at the recent rainfalls, if we look at the rainfall decile maps, which is the usual way that we present our rainfall observations looking over the past few months. And if we look at December, January and February over the summer, we can see that December, relatively high rainfalls in the north, January, relatively high rainfalls in the south, and February was fairly dry overall. So really what that has meant is that there was a subtle, I guess, monsoonal burst in December in the northern part of the country, but really since then it's been quite dry, and they really had a lack of any monsoonal rain following up from that. If we look to the southern part of the country, which is typically a drier part of the year, we really only had sort of average to above average rainfall during January in most parts. So a relatively dry summer, yeah. So I thought instead of also looking at deciles, which essentially rank the amount of rainfall that we get for a certain for that time of year, we also look at effective rainfall, and effectively what that is the absolute rainfall, and we then subtract the actual evaporation. So it's really I guess, a positive or a negative rainfall. So where it's positive, so the left-hand map looking at the green shades of green shows where we've actually had a positive net input of rain. So where we've had rainfall that has exceeded evaporation, and the orange areas show areas where we've had more evaporation than rainfall from the landscape. So we'd expect areas that are orange to have dried out over February. And I guess the thing I just want to highlight is that because as hydrologists, we're not just interested in rainfall, we're also interested in evaporation, because evaporation is the second largest part of the water balance. Of the rainfall that falls, the vast majority of it is evaporated back up into the atmosphere. So typically in southern Australia, of the rainfall that we have throughout the year, probably about somewhere between 70 or 90% of it is evaporated back up into the atmosphere. So it's only probably 10 to 30% that can then flow into soils, flow into rivers, and into our surface water storages, and also into groundwater systems. Also in the tropics, in the northern part of Australia, actual evapotranspiration is probably about 65% of rainfall over the year. So it's important to bear that in mind, and I just want to highlight some areas. So if we look at, now looking just at February, at the rainfall deciles up in the northern part of the country, in northern Queensland and the Northern Territory, we can see relatively low rainfall, but it's a very wet time of year. It's normally a time of year where rainfall exceeds evaporation. And so if you look at those areas in the effective rainfall map on the left, you can see that they're still green, or there's still those green areas, so where rainfall exceeded. So, but for that time of year, it was still relatively dry. And if we also conversely look to the southwest of the country, we can see a subtle blue area there on the southern coast of Western Australia. And normally it's a very dry time of year, very little rainfall at all. And in fact, you can see still the effective rainfall shows that there was certainly a loss of water from the landscape. There was a couple of rainfall events there that led to above average rainfall, but still a very dry time of year. So only a small amount of rainfall can put it up into what we would class as above average rainfall for that location at that time of year. So I mentioned as hydrologists, we look at evaporation. So it's not just about rainfall, but also what evaporation is doing. So here I've got a couple of maps also for February. The one on the left is potential evaporation, again shown in deciles. So it's relative for a particular area for February. So what we would normally expect. So potential evaporation refers to I guess the suction or the driving of the atmosphere in terms of how much water could potentially be evaporated. So things like solar radiation, temperature, humidity, and wind are the key drivers there. On the right-hand side, we've got actual evapotranspiration deciles. So this gives an indication of, in the case of blue, whether we had above average actual evaporation and transpiration, or red, where we had below actual transpiration values of what we would normally expect for February. And so what that really shows is that those red areas, or the areas that aren't as blue as the one on the left, are limited by water supply. So those areas that have dry soils and where we had little rainfall and dry soils, evaporation was limited by the water availability. So that's something that we look at. Now, we don't normally forecast evaporation, so what we do tend to look at is temperature as well, and we'll look at that in the outlooks as well, because temperature certainly has an influence on what sort of evaporation we can expect. So I thought we've now discussed rainfall and evaporation, so and effective rainfall. So now I thought we'd move on to soil moisture. Now, in the Bureau we also provide some soil moisture information. This is not actual information, but modelled information, so it comes out from a model that represents the soil, and we'll talk a little bit about that. But the inputs are the ones I just spoke about, so things like rainfall and evaporation are input into this model on a daily time step, and we model the soil moisture, the available soil moisture across the country on a 5x5 kilometre grid on a daily basis. So here we've got the decile map, again showing areas in blue that are above or very much above average for February. The white areas are average, and the reddish areas are areas that are below average or very much below average for this time of year. So we can certainly see that areas, again up in the north, even though they've had a lot of rain, have had less rain than what they would normally experience this time of year, and as a result the soils are relatively dry. In the southwest, again, even though it's a dry time of year and soil moisture is normally quite low, in relative terms it's above average. And also in Western Tasmania we can see things are quite dry there too, and there's certainly been fairly low rainfall throughout that part of the world as well. So just to also mention that we have a number of, so there are different soil layers. So within the model that's used to develop these soil moistures, here we're looking at the lower layer, which is the area between 10 and 100 centimetres. We find that that's the most useful when we're talking about water availability, and in particular water availability in terms of surface water and stream flows. I thought I'd also include another map. So while on the left I had deciles, on the right we've now got absolute values. So this shows that, and here just highlighting those areas that I mentioned before up in the north, even though they're relatively dry, at this time of year soil moisture is generally quite high because it's a wet time of year, but in relative terms they're dry. Again, towards the south of Perth we can see there's much less soil moisture, but in relative terms it's quite wet. And again in Tasmania, where soils are virtually wet for most part of the year, especially in the western part of Tasmania, we can see it's quite dark blue on the right hand side, but on the left relatively dry. I should also point out, so the values on the right hand side are given in percentages, so they're absolute values, and they're provided on a scale from 0 to 100%, where 0 is effectively the limit at which plants can extract moisture from that soil. So it's really the usable amount of, it provides a limit at which plants can extract water from that part of the soil. And the 100% shows the, I guess the maximum layer or the maximum amount of water that essentially represents water in a soil after it's drained freely through gravity. So again, 100% really shows the maximum amount of water that's available to plants. So, excuse me, between 100 and 0%, that's the amount of water that's available to plants. 100% is also referred to as field capacity, and 0% is often known as permanent wilting point as well. Now moving on to just to give you an idea of how we represent the soil layers within this model, vegetation is also included. So we have a deep-rooted vegetation and shallow-rooted vegetation, which is derived using land surveys and satellite imagery across the country. But the model provides observations at 3 different layers. So at the upper soil moisture, which is between 0 and 10 centimetres or 0.1 of a metre. For the lower soil moisture, which we just looked at, between 10 centimetres and 100 centimetres. And also deep soil moisture, which is between 1 and 6 metres. And as an addition, we also provide root zone soil moisture, which is a combination of 0 to 1 metre. So it essentially adds the top two layers together. And if you follow the links in one of the last slides, which Rebecca referred to, which we'll supply to you, you can look at those sorts of maps for each of these layers as well. So now that we've spoken about climate drivers and soil moisture, we can now look at stream flow and how much water has been flowing in through our rivers. So here we've got a map which has a number of dots. I think there's 236 to be exact around the country, and what they show is for February whether we had low flows, near median flows and high flows. I'll talk a bit about how we've derived those three categories, but I guess what we can see is that for the majority, about half of these locations, we observe low flows across the country, and you can see that they're scattered, particularly up along the northeast coast in Queensland and around Brisbane, and also in some of the inland areas, I guess, along the southeast, particularly in the Murray-Darling Basin, inland of the Divide. We can see some high flow or median and high flows probably along the coastal areas in southeastern Australia. Up in the north, some low and median flows in the Northern Territory. Things are drying out there, as I mentioned, because of the lack of monsoonal rain. And we can see around the southwest of Western Australia as well. Around Perth, flows typically fairly dry, fairly low, but certainly along the south coast there, where we saw above average rainfall, we've also seen that rain flow through to result in above average stream flows. Now, bearing in mind it's a low rainfall and low flow time of year, so we only really require a small increase in stream flow volumes to then result in us tipping over into what we would call high flows. And we'll investigate that a bit more about these categories and how they change for various sites and at various times of the year. I should also mention this map shows 236 sites, and we have a maximum of 242 sites that we provide forecasts for to key stakeholders or registered users. We normally put these locations onto a registered user website and then monitor them for a number of months before moving them to the public website. So we have a public service that currently has 140 locations. So if you want access to these additional locations, then please, you're more than welcome to contact me or follow the links at the end on one of the final slides. I should also mention, if there's any questions in particular that we are not able to address in this webinar, I'm more than happy to receive those via email afterwards, and my email will be on one of the final slides as well. So if we just move and look at how we assess flow categories. So we've divided them into low, near median and high flows. And how we do that is we look at for any given site and for any given season, we look at the historical record. So which if you look on the first chart here, and I'm hoping you can see the red dot there. This particular chart shows the historical record of stream flows. If we then sort them, so we rank them from lowest to highest, and then we group them into 3 equal thirds, and each third has a technical name known as a tercile, but for us we could just refer to them as 3 equal categories. And so what that then represents for this location at this particular time of year is whether flows are a near median, so in the middle third, whether they're well below median, so in the lower third, or whether they're in the upper or higher median, or well above median, I should say, and whether we consider them to be high flows. And so this is actually a plot that we've used for the forecast, but and I'll come to that later on as well. And we then issue forecasts depending on the probability of whether a flow will be in any one of those 3 categories. So whether we have a higher chance of it being low, median, or high flows. And so the previous map we saw showed the most likely, or sorry, that was actually, they were observations, so they showed whether those flows were either low flows, near median flows, or high flows for that time of year. So if we now move on to, and now extending that over time, so at the top right there, I've got the same map that I had up just before of those flow categories across the country. And if we now look and we just add up the number of the different coloured dots across the country, and so we've got February here in the last column. So again, we had about half of the locations had low flows, and so if we now and we had median flows and high flows as well, with fewest high flows. And if we now look at what that map would have looked like, or we count the number of low, median and high flows back for each month, and if we do that, if we look back for a number of years, we'll go back to May 2012 in this case, we can see that we've had a drying trend, I guess, since the La Nina years of 2011 and 12, where we had a relatively low number of low flows. We're sort of getting an increasing number of low flows as the years progress since then, and you can see also the number of, or the proportion of high sites that have high flows is decreasing, and also the proportion of median flows, the light blue colour, is also decreasing over time. And if you particularly look at the southern filling season, so if we look at months July, anywhere from July to October, we see that we certainly the past few years, in 2014, particularly in 2015, we've seen quite a high number of low flows, and that's been a characteristic, and I guess that's certainly affected how our storages have been faring over the past past number of years, and we'll investigate that a bit further. Now, if we just shade out the and we just look at just see how February has been faring, we can see that February for this year is similar really to the last probably 2 years in terms of 2015 and 2014 in terms of the number of low, median and high flows. But again, February being, certainly for the southern season, not being the southern wet season, the southern filling season really doesn't have much impact. It's really that filling season during June to October that's really important, but we've seen quite a high number of low flows. One of the questions we get asked a lot with our forecasts in particular, but I thought I'd address it here, is sometimes we provide forecasts that suggest that we'd have median to high rainfall, and yet at the same time we might suggest that low flows are more likely in those same locations. So I just thought we'd look back at observations for a particular location on the Murray River at Bargara, and I thought we'd look at a period at the end of the Millennium Drought where we moved from fairly dry to relatively wet periods in 2011. And so we've got two plots here, the top one showing the observed rainfall just in millimetres per month over that time period, and the bottom chart shows the observed stream flow for this at the same location for the same time. And if we just draw coloured lines that really provide the boundaries between the and again, these now moving back to flow categories. So these lines, it's above the blue line, signifies the upper flow category where we would class a rainfall or flows as being wet or above median. Between those two coloured lines is where we would define rainfall or flows as being near median, and below the orange line is where we would define flows or rainfalls as being below median. So if we then colour code each of those bars as according to where they would sit in our three category system, we can see that in a number of cases, and particularly if we look at that time, I think it was the end of 2009 where we saw above average rainfall. If we look at the top chart, we can see that rainfall was median and above average for these few months, and yet we still observed relatively low flows. And that's something that we typically see, we typically observe particularly when in times when we're transitioning from dry to wet, and largely because we've still got relatively, well, evaporation is still higher than when it would be in winter, for example, but also because the soils are drier. So what we tend to find is we might have effective rainfall being lowered because of the high evaporation or high-ish evaporation, but also the soils are relatively dry, so the water that does make it into those soils first has to soak up, has to wet those soils enough before we get a real response in stream flows. So the soils are, you can often view soils as a sponge. So if a soil is dry and you have exactly the same amount of rain falling onto that soil, you'll get less stream flow than if that same amount of rain would fall on a relatively wet soil. And similarly, if we look in a relatively wet period in 2011, we had rainfall that we would consider to be well below median, and yet we had a relatively high stream flow for that time of year. Again, note that flows during the summer period are much lower than flows that we might expect during, or they're lower in relative terms than what we might expect during winter. So even though this flow here that I'm pointing at is relatively high for this time of year, it's a relatively dry time of year. And even in a relatively wet time of year, you can have a low flow, which in volumetric terms is still higher than the high flow in a dry period. So I hope that makes sense. And so I thought we'd now then move on to water storages. So our rainfall really over the past few months hasn't been that fantastic, slightly below average, and flows in general have been below average as well. So we'll now look at how our water storages are going. So now we're looking at how water storages are, and I should first talk a little bit about the map that you can see. There are a number of divisions on there, and really that's work been done by the Bureau to divide the country into a number of drainage divisions, and effectively that uses topographic information, so effectively elevation of the land surface to look at how water would flow across the land surface. So the country has been divided up based on how water would flow across the country into drainage divisions, which you see there, and also into smaller units known as river regions. And this is often the way we group our water systems, and it's also the way that we tend to look, that we've decided to look at our water storages. So what we've done here is group all the water storages that are in these divisions and then look at them as a whole to see how they're faring. So here we've got, and so we've got a number of, here we've got 3 plots, and in these plots you can see the bright blue area with the percentage in it showing the percentage full of all of the combined water storages in that drainage division. There's a red line on there which shows the water or the percentage full level 12 months ago, and to the left of that bucket there's a line that shows how that level has been trending over the past 3 years or so. And so what you can see, certainly in the northern part of the country, water storages tend to fill themselves relatively often. In most years, they tend to hit 100%. And in fact, the Gulf of Carpentaria only has, there's only one storage that's located there, so that relates only to one storage. So we often see that one hitting 100% in most years. If we look at the southeast coast as well, we can see a fairly stable pattern over the past few years in terms of storage. That's also particularly because we've had a number of east coast lows that have provided some extra moisture along the coast as well. So those water storages in these areas are looking reasonably healthy. And now we'll look at the remaining water storages across the other drainage divisions. And if we look along the northeast coast of Queensland, we can see you can see the annual pattern of sort of a decline during the dry season and then a filling period during the wet season. And again, over the past few years, we can see a slight decline in the water storage levels. particularly in the Murray-Darling Basin, we can see that quite pronounced, and we'll investigate that a bit further, but we can certainly see quite a seasonal pattern, but steadily on its way down, and we're now well below 40% in the Murray-Darling Basin storages across the basin. We'll look a bit in a bit more detail. Tasmania as well is also interesting. There was partially to do with climate, but also the decision by Hydro Tasmania a number of years ago to take advantage of carbon pricing and generate electricity using the water in some of their storages. So that led to some of the decline we saw a couple of years ago. But really the story in the last 2 years has been the lack of rainfall, which has led to a real fail, I guess, of the filling season over the past few years. So you can see, I think it's back in 2013, you can see there was a filling period there for the Tasmania storages, and really in the last 2 years we haven't seen that happen at all. Now moving across to South Australia as well, we can see that the South Australian Gulf storages are really predominantly dominated by the ones around Adelaide, and in particular don't hold a lot of water. So we tend to see quite a lot of variation in the surface water storages for the South Australian Gulf. And again, they're about 47% full at the moment. Looking at the southwest coast, and we'll look at that in a bit more detail as we will with Adelaide's water supply. Again, the southwest coast, including Perth, very low. Certainly some annual cycle there, but again very low at 23%. But this is not the full story. Surface water for certainly some cities, particularly Adelaide and Perth, is only part of their water supply strategy. So we'll look at that in some more detail as well. Just as I mentioned, we'll just quickly looking at the Murray-Darling Basin. So we've got here what we've done is split up the storages in the northern part of the basin, the southern part of the basin, and what we can see is during 2013 and into 2014 summer there was there was certainly a substantial drop in water storages. I should mention that these water storages are of course a function of the inflows into these water storages, but also a function of the amount of water that's taken from these water storage or used. So it's a balance between what goes in and what goes out, understandably. So there was a remarkable drop in water storages, and they've remained quite low for the past 2 years. Now looking at the southern part of the basin, which is where the majority of the inflows come into, particularly along the southern part of the divide. In Victoria, there's certainly the vast majority of inflows into the basin come from that area. We can certainly see there have been some certainly filling seasons, but they haven't been as pronounced as what they have been in the past. You can see the filling in 2013 in the first part of that chart here. Certainly quite a substantial filling season. Subsequent years we really haven't seen as much of a filling period or as much filling that we would normally expect to see. Now moving on to the next slide, which is sort of looking back a bit, looking at the Murray-Darling Basin, and here we've taken a subset of 87 locations across the Murray-Darling Basin, and you can see where they are in this map up on the right-hand side at the top. So what we've done here is we've classified, looking at observed flows at these 87 locations across the basin, and categorizing them on a monthly basis, whether they're low, median, or high, in the same 3 categories that I've used before. And so that's what the lower part, that's what the lower chart shows, using the same colors. And on the right-hand side here, we've got a split of how many times across this period, which is 1980 until 2015, we see flows in each of these categories. And what we would normally expect to see is an equal split. We'd expect to equally see low flows, median flows, and high flows, probably about 33% of the time, and that's in fact what we do see. So we've got 34, 32, 34 split, which is what we'd expect to see. Along the top here, we've also included rainfall anomalies, so whether rainfalls have been relatively high or relatively low, according to monthly rainfall. And in red, we've shown the El Nino event. So really what we're looking at here is trying to look at how have these flows changed during the El Nino periods. And here we've got El Ninos between that period of 1980 to 2015. So if we just shade out all the non-El Nino years, and so we just look at the El Nino years in this period, and if we now do the same calculation on the right-hand side, instead of having roughly 33, 33, 33, we can see that during these El Nino years, we've had a higher number of low flows. And that's typically what we're seeing this year. This year for the Hume, for example, inflows are about 37%. So they're in that, certainly in that lower part of their flow categories. So that's certainly what we're seeing across a number of the major inflow areas within the basin. I should also mention it's an interesting chart because you can see certainly the influence of the millennium drought. So starting sort of 1997, a few relatively average years here, but certainly after 2000, 2001, out to the end of 2019, you can see a really high number of low flows, and then the impact of the Nina years in 2011, 2012, where we had quite a high number of above median flows, as shown in the dark blue. Excuse me. Now looking at water sources and trends, so trying to extract that a bit longer, briefly looking at urban water sources. So we looked at water sources defined by drainage divisions. If we now look at water sources for the major cities, and here we've got Brisbane, Sydney, again fairly healthy. Melbourne, a little less healthy, slightly declining. We had a very poor filling season end of last year, mid last year, and in fact, for the first time now, Melbourne has placed an order of water from the Wonthaggi desalination plant, which is the first time really that we've had to draw water on that, so that'll be water for next year. And so Adelaide and Perth are the real story. So if we now look up look at these numbers, and what I've included here is not just surface water that these cities have access to, but also desalination, water from desalination plants. So here in these percentages, I've put up the annual supply that these cities can derive from their desalination plants. So they have the capacity to provide additional water if they require. So Brisbane and Sydney don't really have a need to draw on these resources as yet. Melbourne, as I said, will start drawing on that resource as of next year. But Adelaide and Perth in particular are relatively dry cities, and they do rely on other water sources other than surface water. So here I've also included plots now from our national water accounts where you can look at how much water is derived from different water sources. So if we look at Adelaide, Adelaide has increasingly been using desalinated water. So the bar chart here shows green, and the green areas show desalinated water. So there's been a trend over the past few years for Adelaide to start using, certainly when surface water storages are low, to start drawing more on desalinated water. And they also, this middle colour here shows water that's derived from interregional transfers, as Adelaide gets some of its water from the Murray-Darling Basin. If we look at Perth now, we can see Perth has had to really deal with a lack of surface water now for many years. In the 1970s, there was a reduction in rainfall across that area, and they increasingly started using groundwater to supplement their water supplies. That also led to declining groundwater levels, which we'll briefly look at. And in recent years, they've been supplementing their water supply with increasing amounts of desalinated water. And in fact, Perth has a 10-year plan really to start using, to really rely on desalinated water and groundwater in terms of 50% each to meet their their urban water needs. So they're really not relying on surface water at all. But of course we'll use it when available, and can certainly use that for environmental flows as well. So different cities have different strategies, I guess, in how they manage their water supplies. Just quickly looking at Perth, I've identified just some groundwater trends, some increasing trends in some areas, but by and large stable or decreasing trends. And I've identified three particular bores in a groundwater mound to the north of Perth, which was heavily used, I guess, over the past number of years. And so if we just look at the longer term trends in some of these groundwater levels, in particularly since the 1970s, using more groundwater to supplement their needs, and we can see sort of towards the end of the 1990s, certainly an increase in the use of groundwater. And here I've just got three traces of groundwater levels in three different aquifers at three different depths, just to give you an idea of how some of them have been drawn down. And that's largely been induced by the groundwater extraction from those particular aquifers. So if we then also look at how the step change in rainfall has occurred across Perth, and we've got some information in terms of a website known as the Hydrologic References, where we have examined 200 odd locations in terms of the trends in stream flows across these, and we can see that there's certainly been a step change here. We've got Canning River at Glen Eagle, a location just outside of Perth. We can see a step change in 1975, and we can also look at the seasonal distribution. So if we look at the change in rainfall for each month before and after that step change, we can see that certainly in the months of July, August, September and October, which really and also June, which are really the filling season, as I mentioned, well, certainly in Perth is very little rainfall, if anything, for many months of the year, and it's not until May, June, probably until October, possibly November, that they have in the past received substantial amounts of rainfall, which then lead to inflows into their water storage. And really, it's during that time of year that those rainfalls, the rainfall has dropped and has then resulted in relatively low inflows and stream flows into their storages. So we can also look at the trends. So if we look at changes across, as I mentioned, there were over 220 locations. Most of them, many of them, particularly in the southern part of the country, show decreasing trends, and we can see those ones around Perth and also along the southwest coast of Western Australia showing decreasing trends over time, and probably over 40 or 50 years when those stream flow records go back. Again, in Tasmania and certainly across parts of the southeast of the country, we can see decreasing trends. The grey dots show areas or locations where there haven't been trends, and the only area we see increasing trends are those up in the top end of the Northern Territory, and we do see that correlates quite well with the changes in stream flow in rainfall trends as well over that time. And again, you can examine these trends for each individual site by following the links at the end of this webinar. Going from long term to short term, I didn't want to leave out the fact that we also have a 7-day Streamflow forecasting service available now, and we provide forecasts of daily volumes at over 100 locations across the country. We also have a service provided to registered users, so again, if you're keen to look at some additional products, you can. So again, details will be at the end of this webinar, or you're more than welcome to email me for those details. So this gives you an indication of the observations in terms of rainfall and stream flow, and what's likely for the next 7 days in terms of stream flow and also rainfall at a given site. Now moving on to the outlook and the climate drivers. So here we've got, I thought we'd look at what our models are suggesting in terms of forecasts. So here we're looking at Nino 3.4, which is essentially an index that gives an anomaly or a change in temperature difference in sea surface temperatures between the West and East Pacific. So here we're looking at a positive change, so here indicated in the red part or the top part of the chart above 0.8 of a degree difference signifies El Nino conditions, and that's certainly what we've been experiencing since May last year. We can see the observations in terms of that difference up here in the top part of the chart, and really from then on in it's all looking at model predictions, and really what the models are suggesting is that we're we're moving back into a neutral territory here in the middle of the chart. Now the Bureau's model in particular is looking in the middle of the chart here, but we find that we get the best performance or the best indication of what's going on by not just looking at one model but a host of models. So we look at a number of international models to see what they're doing as well, and we look at what most of them are suggesting, and most of them are suggesting we will move back into this neutral territory. You can see one here looking at maintaining El Nino conditions, but the vast majority back into neutral conditions, and indeed one of them is, a few of them are moving into La Nina conditions. So where this index is negative, we might see high sea surface temperatures in the eastern part of the Pacific, and that might well bring more rain or La Nina conditions in the later part of the year. Also, we've got two dotted lines here that show the two El Nino conditions that we observed, we experienced in 97, 98 and 82, 83 as well. And we can see that they also ventured into La Nina territory in the subsequent years. And certainly statistically, that's what we would expect. When we have an El Nino, 50% of the time the following year will go into neutral conditions, or we might have a 40% chance of heading into La Nina conditions, and only a relatively small 10% chance of having another El Nino. So that's what's driving our climate moving into next year. So looking at the rainfall outlook over the next month, or the current month, I should say, we're already partly into this March. The new forecast will be released tomorrow. So I can't show them to you, but I can mention them and that really what we're looking at is in April is probably looking at a similar pattern to what we're seeing in this March map. So probably average to slightly below average rainfall conditions into April, and again probably a dry northern part of the month as well. Across into March, May, also looking like we might get still a relatively dry part of the year, or relatively low rainfall still in the north part of the country, and quite possibly looking at some average or even above average rainfalls in the southern part of the country, which again is consistent with what we might expect at the end of an El Nino. We do sometimes see above average rainfall in the southern part of the country. Similarly with temperature outlooks, the outlooks now here looking at March to May for maximum temperatures, so maximum temperatures during the day and minimum temperatures during the night time. Again, warmer than average temperatures expected, and the outlooks for April to June look similar to this, so we're probably leaning towards warmer days and nights across most of the country. And as hydrologists, we find that important because that's likely to mean that evaporation rates are likely to be higher than what they would normally be if there's enough water to evaporate. So the atmosphere is likely to be warmer and evaporate more water. So now turning to stream flows. Stream flows, again, not surprisingly, we're probably looking at low flows for nearly half of the locations across the country. In Tasmania, probably in the central part, in the northern part of the divide in Victoria, in South Australia, in some parts of the coast, and again up along the North Queensland coast as well. For around Perth, still looking at dry conditions, although in the southern part of southwest Australia we can see still that those relatively high stream flows persisting, even though it's a relatively low time of year. So as I mentioned, high stream flows for this time of year, but still relatively low in terms of total volume. So a mixed bag, I guess, in terms of stream flows, but largely looking at probably more low flows than any other flows across the country. Looking at forecast skill, which is also important to note, our forecast skill really gives an indication of how accurate our forecasts are, or the performance level of our forecasts at different times of year. Generally in the southern part of the country at this time of year, our skill or forecast accuracy is a bit lower than what it is, for example, towards the end of the the filling season. The reason for that is when we move from periods from low to high flows, we find it difficult to, or our accuracy drops a little, because we're often persistent on, we're often reliant on using current flows to forecast future flows. And if flows are relatively low moving into relatively wet periods down the track, our forecast isn't as high as when it might be, for example, in high flow time. So our high flows towards the end of the filling season, so July, August, September, tend to be quite good or very much better in those periods. So that's really what we're expecting for the next few months. So just in summary, El Nino is declining, but it still has an influence on the Australian and indeed the global climate. Also failed to mention the Indian Ocean dipole, another influence to the northwest of the country with warmer sea temperatures, might bring some moisture again across the country. The rainfall outlook, having said that though, the rainfall outlook is still drier than normal in the north and wetter than normal likely in the south over the 3 months, but still April more than likely will still remain dry across the country. The temperature outlook warmer than the normal days and nights across most of the country for the next 3 months. Given that we have dry soils towards the end of summer, in many of those areas, even when the rains do arrive and when they do fall, a lot of that, quite a high proportion of that water will enter into soils before we see appreciable changes in stream flows. And as a result, low stream flows are most likely to occur over the next 3 months. Having said that, though, there are certainly areas along the coast in particular that have received rainfall in the past and that have wetter than average soils where we might see some higher flows as well. So I think that's, I'm moving towards the end now, and I am. So here we've got a link of, or a slide that shows the links to the resources and products that I've shown you during this webinar. But as I mentioned, you're more than welcome to follow these links. And if there's anything you wanted to discuss with me or ask me, then feel free to email me directly at the email that's on the screen at the moment. So I'll leave it there, Rebecca. That's the end for me.
Thank you so much, Paul. That was a really great presentation, I'm sure. I know I got a lot of it out of it, and I know that our participants most definitely did. I just wanted to open up the floor to any of our participants to ask any questions while we've got Paul here. Anything on what you've seen today. Paul's going to hang around for a bit and answer a few questions. If there's something you can't, particularly think about at the moment, or something that's not coming to mind, please feel free to email me and I can pass the questions on to Paul. As well, you can just email Paul directly and he can help you out with anything that you might need. While I give everyone a chance to think of something, if they want to ask something, just in the bottom right-hand corner of your screen, you'll see a document folder. In that document folder, there is a survey. Now, I'm going to be sending this survey out to everybody who's participated and come on board today. So if you can't access it in that document folder in the bottom corner, then I will be emailing it out as well. So yeah, we'll just give everyone a few more minutes. The recording as well is, obviously I've recorded this webinar, so everyone will be getting a copy of this recording as well. And of course, sign up to receive the Bureau communications. You'll find the link as well in these slides, and if I have the permission from Paul, are we able to distribute these?
Yes, that should be fine. Yeah.
Wonderful, wonderful. So I'll send out these slides to everybody who's participated today, as well as everyone who's registered. And I just wanted to say, everybody, don't forget about our next webinar, Where's the Water? Assessing and Accounting for Water Resources. It'll be on the 21st of April. Our speaker, Janice Green, will expand on what Paul's presented today. She'll focus on what we can find out about measuring, monitoring and accounting for water stores, flows, water rights and water use. So that will be on the 21st of April. Those that registration is open at the moment, so if you get off here and you want to pop over and register on the AWA website, that's all up and running and ready to go. So we'll give everybody a couple more minutes and then we shall let Paul go. Just a quick thing, those questions can be asked in that text box. So the text box at the bottom left-hand corner, I did mention this at the beginning of the webinar, and for those who weren't around, Just type any questions that you might have into that text box on the bottom left-hand corner, and Paul can answer them if you've got any. Oh, as we're running out of time, as it is anyway, and my webinar is on a timer, what I might do is if anybody does have any questions, if you could just email me or email Paul, that would be great. Like I said, you will be getting the slides, you will be getting the webinar recording link, as well as those survey questions. If I could ask that survey to be completed as soon as possible, that would be fantastic. And once again, thank you so much for your time, Paul. It's been a really great presentation, and we really hope
Many
to
thanks,
see you on
Rebecca.
again sometime.
It's been a pleasure.